Okay, right. So we're going to look at a GCSE past paper. So this is an Edexcel November 2017 paper. So it's a new spec, it's an Edexcel paper, but even if you're not doing Edexcel, it's still the same concepts. And you should be able to use it's the same information. So the same maths is used across all the exam boards. So 36, so this is a non-calculator paper. So 36 is a product of the primes. We're going to split that. So we're going to half it first, half it again, and then we can't half anymore. So we go to our next prime factor, which is 3. And we can write that as 2 times 2 times 3 times 3. Or you could write it as 2 squared times 3 squared. So that's the first question, hopefully nice and straightforward. Right, question 2. Right, we've got Kiara is 7 years older than Jay. Find the ratio of Jay's age to Kiara's age to Martha's age. Okay, so Kiara is 7 years older than Jay, Martha is twice as old as Kiara. The sum of their 3 ages is 77. So I'm going to try use some algebra and some letters just to make this easy to do. So I'm going to say, let's see, what do we know? We know the sum, so we know K, if you like, plus J plus M is 77. We know that K is the same as J plus 7. And we know that M is 2 lots of K. Right, so let's try put everything in terms of the same letters into here. Now, if you notice, you could put every single thing in terms of K. So we can see that J is the same as K take away 7. So Jay's age is 7 years younger than Kiara, if we think of it the opposite way round. So we've got K plus K minus 7 plus 2K equals 77. So altogether, we've got 1K plus 1K plus 2K. So we've got 4K minus 7 is equal to 77. Now remember, if we want to find out the unknown, we cover up the thing that we want. So the thing that has the unknown in it. So we're going to cover up the 4K. So something minus 7 equals 77. That something has to be 84. So K must be 21. So now we know that we want the ratio of J's age. So we know J is the same as Kiara minus 7. All right. So we know that, where was I? Sorry. J's age is Kiara minus 7. So she must be 14. We know that Kiara is 21, and we know that Martha's 42. So in simplified form, we can divide those all by 7, and we'll get 2 to 3 to 6. So your final answer is 2 to 3 to 6. Right, let's have a look at the next one. So question 3, we've got a parallelogram, and we've got A, B, C, D is a parallelogram, so 2 lots of parallel lines. EDC is a straight line, and F is the point, so it's a straight line. Okay, so we're trying to find angle ABF. So the first thing to do is to identify the angle we're trying to find. So the angle we want is this. So this is the angle that we want. So now let's have a look at the angles that we have and what we know about them. Well, we know that AFB, so this angle here is going to be 35 degrees. And how do we know that? Because we've got these parallel lines So we know that the vertically opposite lines, vertically opposite angles are equal. So we know that AFB equals 35 degrees, and we have to write our reasons. Vertically opposite angles are equal. So we know that's the case. Then we're going to think, what else do we know? We've got BAF is going to be 75. And that's, if you have a look at that, that's because you've got opposite sides, opposite angles in a parallelogram. So opposite angles of a parallelogram are always equal. So we can write BAF is 75. And then it makes it really easy to find that angle we want. And that's opposite angles of parallelogram are equal. And then for our final step, we've got a triangle. So we can say ABF, which is what we want is 180 minus 35 minus 75, which is 70 degrees, because angles in a triangle add up to 180 degrees. You'll write that out as a beautiful sentence. So that's question 3, and we've shown that it's 70. I quite like the show that because you know you've done it right. I know the opposite also is true, but generally you know you've done it right. So we've got a logo that's made up of 3 circles. We're told each circle has a center O. Daisy says 1/3 of the logo is shaded. So what we're going to do is just actually find out what proportion of the circle is shaded. So I would lay it out like this. I'd say we've got our, so if I pull this up a little bit, we've got here. So we're trying to find the amount that's shaded. So the way I'd laid it out, I'd say we've got our big circle, our medium circle, and we've got our small circle. And we're going to try look at the areas of all 3 of those. We're going to look at the bits for all 3 of those. So the area for the big circle is the same as pi times, and let's think what our radius is, 4, 5, 6, 7, 8. So we've got the biggest circle has what radius? So if I think about my biggest circle, so if I think about a small circle, I can see is 4. The medium circle is 4 plus 3. So my medium circle is 7. And my big circle is going to be 4 plus 3 plus 3. So that's going to be, your big circle is going to be 10. So you've got your 3 radiuses. So you've got 10 squared. Here you're going to have pi times 7 squared. And here you're going to have pi times 4 squared. So you've got 100 pi, 49 pi, and 16 pi. Right, now, what's the shaded area? The shaded area is the medium circle minus the small circle. So that's going to give you all this bit here that's shaded. Is if you have the medium circle, take away the small circle. So you'll write the shaded area is 49 pi minus 16 pi to give you 33 pi. My total area, so the area of the big circle, is 100 pi. So if we do 33 pi over 100 pi, the pi's cancel. We're left with 33 over 100, which is not the same as 1/3. So is Daisy correct? Daisy is not correct because it's not exactly 1/3. So Daisy is not correct. Right, so we've got our medium, our big, our medium, and our small. And we're looking at the shaded area. All right, so I'm going to move on to the next one. I know it's going quite fast, but they are recorded. And I just want to try get through as much as possible in about 45 minutes. Okay. So the table shows information about weekly earnings of 20 people who work in a shop. We want, the key bit here is obviously it's an estimate, and we've got group data. So when we have group data, what we need to find is we need to identify our midpoints, because we're going to use our midpoints. So our midpoint of 150 and 250 is 200. Midpoint here is 300. So they've made the numbers relatively nice, 400, 400, 500 and 600. And then in order to do the mean, we want to work out we need to work out the total at the top, which is going to be our midpoint multiplied by our frequency. So we want our midpoint times by our frequency. So in order to do that, we're going to have 200 times 1, which gives us 200, plus 300 times 11. So do 3 times 11, which gives you 33, and add the 2 zeros. 400 times 5, so 4 times 5 is 20, and our 2 zeros. 500 times 0, which is just 0, so I'm going to write it only because when you'd be doing your checking at the end, you could tick off that you'd done every single one of them if you had time. 600 times 3, 6 times 3 is 18, and our 2 zeros, and that's going to be all over the total people, which is 20. So when I add those all up, I get 7,300 over 20. I can cancel my zeros out. So I've got 730 over 2. Remember, it's non-calculator. So you're thinking to yourself, how can I half that? So you could either do a division, or you could say half of 700. So you know that half of 700 is 350, and half of 30 is 15. When I add that together, I get 365. So my answer would be 365. So an estimate for the mean earnings would be 365. Then the next bit of the question says, and if you can't see it on your screen, it says the mean may not be the best average. Do you agree with this statement? So Nadia says the mean may not be the best average to use to represent this information. So why is the mean not always the best average? So sometimes the mean isn't the best because it's affected by extreme values, right? So the mean will be affected by extreme values, so the median may be better. So whenever you get asked that, you just think, okay, well, the mean, if I've got an extreme value, it's going to be affected by it, where the median is not affected by that. Right, next question. So the next question we've got a rectangle here. So all the measurements are in centimeters. The area of the rectangle is 48 centimeters squared, and we have to find what y is. So we know that the area is 48, but we also know it's a rectangle, which tells us that this side is equal to this side. So the two sides of the rectangle, so we know that therefore this tells us that this must be the same as this, because the lengths are the same. So before we even start, we can say, well, we know that 2x plus 6 equals 5x minus 9. We can, well, we probably want to put the x's onto the right-hand side. So we're going to minus the 2x this side, minus the 2x this side. So we end up with 6 equals 3x minus 9. We're going to say something minus 9 equals 6. That's something which is your 3x. I'm just putting it here just to make it easier to see, is 15. And then you can see that 3 times something is 15. That something must be 5. So now we know that this side is 2 times 5, which is 10, plus 6, which gives you 16. And I'd always do a double check. And in an exam, check as you go along. So 5 times 5 is 25, minus 9 is also 16. So you know you've done it right. We're now told the area of the rectangle is 48 centimeters squared. So we're going to have the length times the width gives us 48. So we say something times y is 48, and that tells us y equals 3. And even if you weren't sure of that, we're told to show that y equals 3. So you can just do a double check by going backwards and doing 16 times 3 and checking that you get 48. So use the answers to help you when you're in an exam. Right, question 7. Right, only 1 mark, and we've got a graph here, and it's saying what is wrong with this graph. Now, hopefully you can see that the graph is made up of straight lines. We're used to seeing, whenever we see a curve, we expect it to be like smooth. So we'd say he should have drawn a curve with smooth lines. So it shouldn't be this disjointed straight lines. No, this isn't foundation, this is a higher paper, but the first few questions that we're doing should be relevant on a foundation paper as well. Right, so question 8. Write these numbers, let me move my face that way. Write these numbers in order of size. So how would you go about? I extend them slightly to make sure I understand. So wherever you've got the dots above a number, that's the bit that's repeated. So this is actually 0.2464646 ... This one's the same as 0.246666. This is a dot on the 2 and on the 6. So that tells us, take some of those out so we've got some space. That tells us the whole thing is repeated. So it's 0.246, 246, 246, and so on. And then we've got 0.246. Now, if we notice, the first 3 digits are the same in everything. So what we need to be looking at is the number after that. So we're going to look at 4, 6, 2, and in this one, it's a 0 because there's nothing after it. So that means the 0 one is the smallest. The one that has a 2 afterwards is the next one, which was 0.246 with the dots on the 2 and the 6. The one that has a 4 afterwards is the next smallest, 46, with the dots on the 4 and the 6. And then the largest number is the one with the 6 recurring. So that's the easiest way to think about which ones are greater. Right, James and Peter cycled along the same 50-kilometer route. James took 2.5 hours to cycle 50 kilometers. Peter started to cycle 5 minutes after James. He caught up with James when they had cycled 15 kilometers. They cycled at constant speeds. Work out Peter's speed. Okay, so how are we going to go about this? So we know we could use, so there's 2 different ways you could think about this, but let's take, I guess, our triangle where we've got speed times time gives you distance. So what we've got enough information, we know that James took 2.5 hours to cycle 50 kilometers. So James's speed, if we cover up the S, is his distance, which is 50, divided by 2.5. So you've got 50 divided by 2.5, which gives you 20 kilometers per hour. So remember, dividing by 2.5 is the same as, so if it took him, the other way to think about it is 50 kilometers took him 2.5 hours. So if we're doing it without a calculator, we can say Well, how many lots of half hours are in 2.5 hours? There's 5 lots, because 1 whole hour has 2 lots, the second whole hour has another 2 lots, and then the additional half an hour. So we know 1 lot of half hour would be 50 divided by 5, so that would be 10 kilometers. So in 1 hour, he goes 20 kilometers. And that gives you how much, so this is just telling you how much he travels in 1 hour. So 20 kilometers per hour. We know that for 15 kilometers, James's time, so what's his time? So let's see. So for the first, Peter caught up with James when they'd cycled 15. Okay, so 15 kilometers. We take James's time, which is going to be his distance over his speed, which is going to be 15 kilometers over this 20 kilometers an hour that we calculated, which when we can cancel down gives us 3/4. So that's 45 minutes. Okay, so that's the information that we can get about James. Now let's think about Peter. So it took Peter, so he left 5 minutes after James. So it took Peter 40 minutes to cycle 15 kilometers. So we want to know how long it would take Peter to cycle, so how many kilometers he would cycle in 1 hour. So let me write this somewhere that you can see it. So we've got, we've got 40, let me try right on the bottom. So we've got 40 kilometers, so 40 minutes, so 15 kilometers in 40 minutes. So therefore, if we want to get to 60 minutes, I think the easiest way without a calculator is half it to get to 20 minutes. So half of 15 will give you 7.5 kilometers. And then to get to 60 minutes, you're going to multiply that by 3. So you're going to double it and add the 7.5, so you get 22.5. Now, if you wanted to do 15 over 2/3 and you could think of it in terms of the maths, that's fine. But in a non-calculator paper, try and make your numbers as easy as possible for you to work with. Right, let's have a look at question 10. So this is nice and easy, 1 mark. What does the power of half mean? So anything, any value to the power of a half is the square root of that value. So 100 to the power of a half is going to be 10. And then we've got 125 to the power of 2/3. So we have to say, all right, let's split that up. We've got 125, we could say to the 3rd and then squared. Now, if something to the power of a half is a square root, something to the power of a 3rd is the cube root. And in a non-calculator paper, is it in hours, not seconds? Yes, it's in hours, but because we were looking at 1 hour, sorry, I'm just answering a question. Because we were looking at 1 hour, we were trying to get to 60 seconds. So we looked at how long it would travel in 20 seconds, then in 40 seconds, and then in 60 seconds. So anyway, so we've got a to the 3rd equals the cube root of a. So therefore 125 to the 3rd is going to be the cube root of 125, which is 5. We're going to square that, which gives us 25. So all the squares and cubes that you should learn for the non-calculator or be able to do quickly tend to be 2 squared, 3 squared, 4 squared, 5 squared, maybe up to 6 squared and cubed. But there'll always be numbers that are easy to calculate or you should recognize. All right, so the next question. We've got 3 teas and 2 coffees at a total cost of $7.80. And we've got 5 teas and 4 coffees at a total cost of $14.20. So hopefully you can see this is a worded simultaneous equation question. So with our simultaneous equations, I'm going to call the T's the letter T, the coffee's the letter C. So I'm going to get 3T plus 2C equals 780. I'm not going to bother with the zero, I should put the zero. And then I've got 5T plus 4C equals 1420. And I'm solving these simultaneously. Now you can either make the C's the same, or you could make the T's the same. Now, I'd probably make the C's the same by multiplying the first one by 2, but say you didn't see that, and you decided to multiply that one by 5 and that one by 3. That's going to become 15T plus 10C equals 780 times 5. So I would do that by doing 7.8 times 10, which gives me 78, and then halving it to give me 39. 5 times 3, that gives me 15T plus 12C. Now 1420 times 3. Now if you need to do a sum on the side, you can do. So times 3, so you'd have 0, you'd have 6, 4 3s are 12, and then 1 times 3 is 3 plus 1 is 4. So you've got 4260. And what we're now going to do is we're going to take one away from the other. And I'm going to take, if I call this 1 and 2, I'm going to do 1 take away 2. So I'm doing the second one that as I've written it, take away the first one. So I end up with a positive, like a whole number, a nice number for C. So these cancel, these will disappear. 12C minus 10C gives me 2C. £4.60 minus 39, so I'm just going to add it there. So when I do that, I get 0, 6 minus 0 is 6. I'm going to have to borrow 12 minus 9 gives me 3. So I end up with 2C is £3.60. I'm going to half that. Half of 3 is £3 is 150 plus half of 60, which is 30. That gives me £1.80. And then I just go back to my original equation. So I'm going to go back to that one, substitute it in. 3T plus 2C. So I'm doubling 2, which I have above anyway, which is 360 equals £7.80. That tells me 3T, £7.80 minus 360 is going to give me £4.20. And so T is going to be, so if we do 42 divided by 3, we get, so we could do it that way around. So or even if you do 4 divided by 3, so you're going to get £1.40. So the T is £1.40 and the coffee is £1.80. And that's an example of a simultaneous equation which comes from some worded, so you're going to get marks for creating these two, and then you're going to get marks for solving it. But even if you get in a muddle, continue to go through the process, get a value for T, you're getting a mark for substituting it back in. Right, so the next question is, if I remember correctly, well, yeah, on a box plot. So a box plot, so here we go, we're going to draw a box plot for the information, this information. Now, a box plot is always drawn, I'm just going to draw, this isn't this box plot, just to illustrate. This is always your lowest value. This is your Q1, which is your lower quartile, which is 1/4 of the way through the data. This is your Q2, which is your median, which is halfway through your data. This is your Q3, which is your upper quartile, which is 3/4 of the way through your data. And then this one is your highest value. So you've got your lowest value and your highest value. And you can see here, you've got a scale across the bottom. So you'd have to plot it accurately. Okay, so I'm not doing this beautifully or accurately. I'm just going to put it approximately, looking at the numbers where it should be, just so we can sort of talk about it in the next bit. So it's about there. You'll have to excuse mine, but you'll obviously draw these lines. So this line will match up to 154. And because the range is 20, the highest line must match up to 174, because this whole space has to be 20. And also your interquartile range, which is your difference between your lower quartile and your upper quartile. So that's telling you this space here has to be 7. So that's the information that you would need in order to plot that diagram. Okay, so if I get rid of some of these and scroll up. The question then tells us to compare, so I'm going to clear all that. Compare the distributions. So when they're trying to compare the distributions, you're looking at this and you can read off the median value. So the median value here is the median value that we had was 165. This is very clearly smaller than 165. So my first point would be the median height. Okay, the median height of year 11 girls is higher. And then the other thing that you always talk about is, so you'll always talk, if it's a mean and a standard deviation question, you talk about the mean. If it's a median and an interquartile range or median question, you talk about the median. And then the other thing is you talk about the spread. So that's either talking about the standard deviation or the interquartile range. So in this case, you're given an interquartile range, and you say the interquartile range of year 11 is girls is smaller because there's less space in the higher one, or there's more space here. It doesn't matter which way round you write it. Okay, so let's have a look at the next question, which is about pies. So a factory makes 450 pies every day. The pies are chicken pies or steak pies. Each day, Milo takes a sample of 15 pies to check. The proportion of his pies in his sample that are chicken is the same as the proportion of pies made in his sample is the same as the proportion made that are chicken. On Monday, Milo calculated that he needed exactly 4 pies in his sample. Work out the total number of chicken pies that were made on Monday. Okay, so if every day he takes 15 pies to check, we know that 4 out of these 15 are going to be chicken pies. And that's out of a total of 450. So we've got now, if we've got a fraction times a whole number, we can just imagine it's 2 fractions multiplied. Now we could multiply the top and divide it by multiplying the bottom, but we're going to make life a little bit difficult. So we're going to think, what do we know for definite goes into 450 and 15? So I can do it either diagonal or up and down. I look up and down and I can see that doesn't cancel. So I can look at diagonally. So let's say you don't see it's 15. Let's say we know it's 5. So we can cancel that and we'll get, if I divide 15 by 5, I get 3. 45 by 5 is 9. And then I've got a 0, so that's 90. And now hopefully you can see they both go into 3. You could have done it in one step if you saw it. And so that's going to become 30. 4 times 3 is 12. We add the 0. So the number of chicken pies that were made on Monday is 120. On Tuesday, the number of steak pies needs in his sample is 6 to the nearest whole number. Milo takes at random a pie from the 450 pies made on Tuesday. Work out the lower bound of the probability that the pie is a steak pie. So whenever you're thinking about bounds, we think about, okay, so we've got 6 to the nearest whole number. So I'm going to put the number before and the number after. And I say, what rounds to 6? So anything 5.5 and bigger, and anything smaller than 6.5. But because it could be 6.49999999999, we still just make it 6.5. In order to work out a probability, we know we're going to be dividing it by 15 because that's the sample, and we want the lower bound. So we're going to take the lowest number. So we're going to take this 5.5. Now the problem with it like this is the probability has to be a fraction, but we don't have a decimal on the top. So we could double the top to make it 11 and the bottom, and that doesn't change the fraction. And now we can't cancel that down anymore, so that's our answer. So the probability, the lower bound of the probability is 11 over 30. Right, so now here is where everything that could come up after this is likely to be will only be in a higher paper, and it's where it gets a little bit more trickier. So we've got time to go through a couple of more, and like I said, I'm going to finish off these 2 papers this evening and tack them on to the end, but you'll be able to re-watch the live until that point on YouTube if you need to, because I have gone quite fast. So we've got a ratio, and we've got its equivalent to k(1). So what is a ratio? A ratio is also a fraction. We can also write ratios of fractions. So here we've got y plus x (y minus x). So that ratio dot could also just be a divide sign. So we know that that is the same thing. And then we're saying it's equivalent to k(1). Equivalent is an equal sign, k over 1. And now we're taking this and we're rearranging it to make y the subject of the formula. So I'm going to bring that y minus x up. So I get y plus x equals k y minus x. So I'm going to open out the brackets on this side, ky minus kx. What I'm going to do is change that negative into a positive. So I'm going to put all my y's onto one side and all my x's onto the other side. So that's the aim. So I'm going to move this one onto this side, and I'm going to move, so that's going to become y plus x plus kx equals ky. And then I'm going to move the y onto this side. So I'm going to get x plus kx equals ky minus y. I can factorize both sides, so I can take the x out, I get 1 plus k. I can take the y out, and I get k minus 1. And now I'm going to draw up here. I can bring the k minus 1, I can divide onto this side. So I get y equals x 1 plus k over k minus 1. I've just moved them onto either side just to make it easier to see, but it's the same as x 1 plus k over k minus 1 equals y, because that's what you're left with. So you've shown the answer, and that would get you the marks for showing it. But because it's a show that, you need to write out every single one of the steps. So this is a non-calculated GCSE higher paper. Right. If we now, this is the final question that I'm going to do. So we've got, for today anyway, we've got x equals 0.436 with a dot on top of the 3 and the 6. So what we've got is, if we think about that, we've got x equals 0.436363636. And your aim with all these types of questions is the thing after the decimal place. You want two things where it's exactly the same. So if I was to times it and just keep timesing it by 10 until that happens, I get 4.363636. Okay, we can see there's a difference here. If I times it by 10 again, 100x, I've got 43.63 63636, so it still doesn't work. But if I do 1000x, I get 436.363636, and now I can see that this is the same as this. So I'm going to be using my 10x and my 1000x. So I'm going to take them away from each other. So if I do 1000x minus 10x, on this side, I'm going to get 990x. If I do 436.3636 minus 4.36, the 0.3636 bits are just going to cancel out. And I get 436 minus 4 to give me 432. So x is 432 over 990. And I want to simplify that down. Now, because they've told us that it's 54 over 55, you could actually say how many times does it go in, but say they didn't and it wasn't obvious for you to see. So you'd say, okay, what do I know that both of these go into? So you could see that 990 goes into 3. And a way to check whether 432 goes into 3 is to add up the digits. So you can say 4 plus 3 plus 2 gives you 9. And because that's divisible by 3, it means that 432 can definitely be divided by 3. So the bottom divided by 3 would give us 330, and the top, 432 divided by 3, 3's into 4 gives us 1, 3's into 13 give us 4, and so we get 144. And now we could see again that if we were to add it up, we get 9. So we can see it, we can divide by 3 again. The bottom will become 110. We divide this by 3. So 144 divided by 3 gives you 3's into 14. So 3's into 14, which gives you 4. And so you're going to end up with 2 left over. So you've got 8. Yeah, that's right. So you get 48 over 110. And then you want to cancel down. Well, now you can see if you half the top and the bottom, you get the answer that you want. So that's how you would prove algebraically that that recurring thing can be written as that. I can see your students on. Oh. All right, so I see how you go, see whether it makes sense, and we can continue this later. I will make sure I put up the rest of this paper. So in total, there are 23 questions. So we've done more than half. And hopefully this was useful. And make sure you ask me lots of questions. And if you do need any more help,